Hi, welcome back to Mathematical Maths. So today we're going to do different types of differentiation, like what the differential of ln of x is, tan of x, just different things like that. We're also going to have another person on today, and he's going to act as a student. So any questions you have or something like that, hopefully they pass through him as he tries to understand these different things.
I'm going to ask the questions you might have.
Yeah. So anyway, time to get started. So we're going to start off with what the differential of y equals ln of x. So this, without doing the proof and everything like that, just know, normally you'll have it in your formula booklets, but that's just going to be equal to 1 over x. Okay? Now the next one, have you got any questions about this one?
No.
Okay. So what the next one we're going to do is, let's see how y equals tan x. Right, the way we can prove this is by saying that equals sine x over cosine x, and then from there we just use the quotient rule, and then we'll be able to simplify
How do we
it to.
use the quotient rule?
And the quotient rule is like the bottom part squared, so cosine squared divided by, and then we take the derivative of this multiplied by this divided or subtract by the derivative of this multiplied by this, and those just end up cancelling out. So we have 1 over cosine squared, okay? And that just simplifies to sec squared x. And that's what the derivative of tan is, okay? So the next one we're going to do is y equals ex. Now e is a really cool number because basically what happens, anytime we differentiate it, we always stay with the initial term multiplied by something. So we're going to have y prime, or the derivative with of dy with over dx. We're going to have e to the x, that always stays there, multiplied by the derivative of the top part. And the derivative of x is just 1. So that's just ex.
So if the x were to be 2, it will be 2e.
Exactly.
The power of x, right?
Yeah, so if we had y equals e to the power of 2x, we'll have y prime equals e to the power of 2x multiplied by the derivative of that, which is just 2. Yes. And that's that derivative. Okay? So if we had, for example, a crazy function like y equals e to the x squared, how do you think you do that? So remember we said anytime you have e to the x in the differential, that term always goes, you'll always find that.
It's going to be x squared times e to the...
You'll have this,
Yes.
but then you multiply by the differential of x squared. And what is that?
2x.
Exactly, yeah. And that's the differential of that. Do you understand?
Yeah.
So if I was to have another one, maybe like
So here,
this cubed, what do you think that is?
so here is going to be the derivative of this thing.
Yeah.
Right, so it's going to be 3.
Can I go? So this is y equals 3. Oh, that's very, very close. The only thing is here, remember, when you have the exponential value, you take the derivative of this. And what's the derivative of this?
3x squared.
3x squared. Exactly. So you're going to have to replace 3x squared.
So don't forget it.
Yeah. Okay, so the next one we're going to do is what happens when you have a function like y equals a to the x, okay? For now, we'll say what happens when we have, we'll put a to the x, because then we'll be able to use that in any example. So do you have any idea of how to do this?
I don't have it.
Okay, so what we can do is, we're not so sure how to integrate when something is per of x, but what we can do is bring that to the front. So a and x are on the same level. So we know if we have anything to the e to the power of ln of a, that's the same thing as writing a. Okay?
Why?
That's because ln is log base e, and anything to the, so if I had like 5 log base 5 of a, those cancel out.
Right.
Okay? And then,
Just a.
exactly, so we're just left with a. So what we can do here is we can do the same thing. We can say it's going to be e to the power of ln of a to the power of x, and using our log rules, if you have the ln of a to the x, we can bring the x to the front, right? So we can do the same thing here, x to the front. Now we just have the exact same thing as we did with the previous one when it was like e to the power of 5x. So what happens first is we know this function is going to be in here when we take the derivative, because this is just, up until now we've just rewrote it as a different thing. Okay?
Yeah.
So what we're going to do here is we know this part is going to be in here, so it's going to be this e to the power of ln of a multiplied by x, okay?
Yeah.
And then that's going to be multiplied by the derivative of this.
What's the derivative of ln a? Is it 1 over x?
No. This part is a bit different. So imagine if we had 5x. We wouldn't take the derivative of 5, right? We take the derivative of x, and then that influences the 5, so we're left with just 5. So we can have anything, like for example, if we had ax, and we take the derivative, we're just going to be left with a. So for example, if we have ln of a, we'll call that c for now. So we'll have c, which c equals ln of a. If we take the derivative of this, we're just left with c, right?
Yes.
Because we need to bring the derivative to the front, and we know c is the ln of a, so we're left with this. But we can simplify this, because remember I said, if they have the same terms, they can cancel out. So the derivative of a to the power of x is the ln of a multiplied by a to the x. Okay? So if I was to work backwards, this is just like a quick example of the integration. If I had, for example, integrate a to the x, what would happen is we do almost the exact same thing. We do almost the exact same thing as when we're differentiating it. So we'd first start by rewriting this as the integral of e to the ln of ax. Okay? Now we can bring the x to the front and we'd have the same thing. E to the power of ln of a multiplied by x, but we'll call the ln of a c. Okay? So c equals ln of a. Now what happens is we need to integrate this, and we know when integrating, the e always stays the same. So we know we're going to have e to the cx divided by, because that's what happens in integration, right? Yeah, join me. So like for example, if I had integrate 5x to the power of 2, what would happen is it would be x to the 3, 5 divided, right? So what's going to happen here is we're going to divide by the c part, or the differential of this top part. Because anytime we differentiate the function, we know that this part will stay the same. So we know that part is the part that's been multiplied. So to undo it, we're going to just take the differential and divide. Okay? So we're going to divide by c, and that's just the same thing if I rewrite this. It's saying e to the power of ln of a to the power of x divided by the ln of a. That cancels out. So ax, or a to the power of x divided by a. And that is the integral of that. This. So, do you have any questions or?
No.
Okay.
I have a question.
Sure.
What is everything? Just cut that part out.
Okay. Anyway, thanks for watching, and don't forget to subscribe, like, and all these different things. And
I'm the cameraman.
next time we're going to be doing some integration and with substitution and stuff like that. So thanks for watching, and stay mathematical.